Curvilinear coordinate system 17. Consider a scalar function phi of position which depends on the cylindrical coordinates rho, phi, and z such that the scalar function phi is equal to rho cosine phi. Part A, plot the surfaces of constant phi in the xy plane. So we're going to postpone this to the end, and we will work on part B. Let the vector v be gradient of phi, and find the radial v rho and azimuthal v phi components of v. So that's what we're going to work on. So we can recall that the gradient operator in curvilinear coordinates is given as qi hat over hi, the scale factors, the partial derivative with respect to qi. And now our scalar function phi in this case is equal to rho cosine phi rho cosine phi. These are our cylindrical coordinates, rho and phi. And the position vector is given in Cartesian coordinates as x ex hat plus y ey hat plus z ez hat. Now, the coordinate transformation equations between the cylindrical coordinates and Cartesian coordinates are x is equal to rho cosine of the azimuthal angle phi, y is equal to rho sine phi, and z is the same in both coordinate systems. So z is equal to z. So with that, we can substitute these equations into the position vector r. We're going to get rho cosine phi in ex hat direction plus rho sine phi in ey hat direction. And finally, we have z in ez hat direction. Now, in order to calculate the scale factors, we have to take the derivative of the position vector with respect to each of the cylindrical coordinates. So we start with rho, del r del rho. You can see here this derivative will be cosine phi, this will be sine phi, and no contribution from z part. So we will have cosine phi ex hat plus sine phi ey hat, and if I take the magnitude of this will give me the scale factor h sub rho. It's the magnitude of del r del rho, and you can see that this is square root of sine square plus cosine square. So we have cosine square plus sine square. And that's simply equal to 1. So the scale factor is 1 for rho. And if I work on del r del phi, then I'm going to get a minus rho sine phi from this derivative and plus rho cosine phi from the y component. So we will have minus rho sine phi in ex hat direction plus rho cosine phi in ey hat direction. And this will give us a scale factor h sub phi that is the magnitude of del r del phi. And you can see that in this case, I'm going to get rho parentheses square root of sine square plus cosine square. Therefore, this is going to be equal to rho in this case. And finally, I have the scale factor for the z component, del r del z. Del r del z is simply equal to ez hat, implying that the scale factor is 1. Now we're ready to write gradient of this scalar function v, which is the gradient of phi, and that's now given in the Cartesian coordinate system. It's going to be 1 over h rho, the scale factor, e rho hat del phi del rho, and then we have 1 over h phi e phi hat del phi del phi, the scalar function, and the angle, azimuthal angle phi. And finally, I have 1 over hc ez hat del phi, scalar function phi, partial derivative with respect to the coordinate z, cylindrical coordinate z. Okay, and now looking at what I have for h sub rho, it's 1, so it's going to be e rho hat del phi del rho. What was phi? Phi was rho cosine phi. Therefore, I'm going to get a derivative with respect to rho, giving me cosine phi. So I'm now ready to write the vector v, 1 over h rho del phi del rho. That gives me cosine phi because it was rho cosine phi in e rho hat direction. And then I have 1 over h phi, that was rho. So rho cosine phi divided by rho, and I'm taking a derivative with respect to phi. That gives me a minus sine phi. So this would be minus sine phi in e phi hat direction. So I'm ready to answer the question, what is the rho component of this vector v? It is cosine of the azimuthal angle phi. And what is the phi component? It is minus sine phi. All right, so in this problem, we're working with cylindrical coordinates rho, phi, and z, and here we have a scalar function given in cylindrical coordinates rho cosine phi. So we're defining the gradient of phi as a vector v, and we want to find the radial and azimuthal components. So we recall the definition of the gradient in the curvilinear coordinate system qi hat over hi del del qi. Therefore, I have to write the position vector, substitute the transformation equations for x, y, and z, take derivatives with respect to each of the cylindrical coordinates, and take the magnitudes of the derivatives. That gives me the scale factors 1, rho, and 1. And then the gradient is 1 over h rho e rho hat del phi del rho plus 1 over h phi e phi hat del phi plus 1 over h c e z hat del z. Now, the phi doesn't have any z in it, so this gives me 0. Del phi, the derivative with respect to phi gives me minus rho sine phi divided by h rho, which is h phi, which is rho, gives me minus sine phi for this term. And here I have the scale factor is 1. I'm taking the derivative with respect to rho, so I get cosine phi. Cosine phi in e rho hat direction for this term. So cosine phi e rho hat minus sine phi e phi hat. Therefore, radial component is cosine phi, azimuthal component is minus sine phi.